Hi, my name is Chris Gavan. I'm a senior software engineer from AWS, and today I'm going to show you how to extend the O3DE editor through modifying existing tools and by creating your own custom tools as well. This can be done in both C++, which most of the editor code is written in, as well as Python. All of the UI you see in the editor, with the exception of the viewport, uses the Qt library, which is a cross-platform widget toolkit and application framework. I'm going to show you some practical examples of building tools on top of this framework. Before a deeper dive on our usage of the Qt widgets library and our code architecture, I would recommend watching the Editor 101 workshop. At the end of the presentation, there will be a link to the UI/UX SIG Discord channel where you can ask questions about all these topics. All right, let's begin. We're going to start with the simplest example, which is modifying an existing tool in C++. I already have my editor running. I'm using the multiplayer sample project from the O3DE GitHub, but you can actually create your own project as well from the project manager, and it'll have all the right gems and dependencies necessary in order to follow along for this tutorial. So to set up this example use case, I'm going to go ahead and start by creating a new level, and I'm going to bring in some of the prefabs that are present already in this project and have been iterated on quite a bit. So for this example use case, when you're looking at prefabs in the editor, there's no way of seeing who modified them last or how many times they've been modified. And this is really the same for any kind of asset, but it comes up the most in prefabs since they could be ultimately touched by many different people adding different components to them or adding or removing child entities. Of course, you could go into whatever version control you're using. In our case, it's in Git, and you can look at the actual Git log to see who has been modifying it, but this would be cumbersome to sort through and look at all the different diffs. And so I thought it would be a good use case to actually show a way of adding a menu option to a prefab to actually extend this right-click context menu on a prefab, and we're going to add an option to show the Git history in the editor, so you can actually, without leaving the editor, you'll be able to show some metadata on individual prefabs. And this could be extended to any asset as well, but this will be a good, simple example of extending an existing tool and specifically a context menu item. So diving into the code, I'm in the Prefab Integration Manager. There is an editor context menu bus that has an API populate editor global context menu that allows you to inject any different menus and submenus onto a global right-click context menu event. And so that is where we will add our code to display our custom dialog for showing Git history on a prefab. Now, I knew to come into this API already, but if you were just trying to extend something on the UI, a good way to usually find things is by searching for that actual user displayed string. So in my case, I know I was wanting to add it right underneath the edit prefab action, and so there should typically only be a small number of these that will allow you to search for them. Another way of finding where in the code you want to add something just from looking at the editor UI itself would be the object tree tool, which I'll go over later because that tool is actually written entirely in Python. So we'll start with a little hello world example as part of this, just to make sure that we're in the right place. So I've already written some code here. We are creating a new action on the menu that was passed in through this API. This string here will be the actual label that shows up in the menu for the action that will be able to be triggered by the user. The reason why it's wrapped in this QObject_tr call is so that it can be passed to Qt's translation system so that ultimately the editor could be translated into multiple different languages. So then we're going to connect to the actual hello world action, and when it's triggered, we're going to create a new dialog, give it a title, give it a simple layout, and then we're just going to add a single Q label, which is a string display, and add it into our layout, and we're going to show it. So let's see what happens. So I've reloaded our demo level with our changes we just made. And you can see now if we right click on a prefab, we have our action that we added in the code. And if we click on it, then we get a little hello world dialog. We can see it again if we click on this other prefab as well. And you'll notice that if you right click on a normal entity, you do not get this option, which is what we would expect. So let's jump back into the code and make this dialog show some actual data. I've added some code here that'll show an actual dialog that contains a table with some of the data from Git. And so I'm just going to step through it. It starts off the same. We add an action to our menu with a different title. The difference in the second line, we're passing into the Lambda, we're capturing the prefab file path, which we already had in this portion of the code because we're adding our menu option under an edit and save prefab options that were already existed in the menu. So they already needed the prefab file path, so we can just make use of that. In the actual execution logic for when the action is pressed, we're going to start off by creating a little sub-process in Qt, and we're going to use the working directory as our project path so that we can run the git log command. I can show you what it would look like if we were just running it from the command line ourselves. So running the git log, and I've formatted a string that just has the hash, the date of the commit, the author's name, and then the title. So we can kind of see what it looks like on one of the prefabs in the multiplayer sample project. And so we'll get a bunch of new lines for each commit. Each of them, and all those categories of data will be separated by, I just picked semicolon because I noticed that no one had used them in the titles, and so it works for this. Obviously for if we were doing actual data manipulation, we would want to put it out in some kind of JSON format, but it works. This will work for the purposes of our example. So I build those into a crew string list for the arguments to pass to Git for the log. We have to wait for the process to be finished in this case because this is an asynchronous operation. And then we'll read the output. And then similarly, as we created the Hello World example, we'll create a dialog, and we have a vertical layout that we're going to have so that we can get some stretch in there. And then we have some pretty simple splitting of the output by new lines because that's how we had formatted it. And for this table, I'm actually using a QTable widget, which derives from the QTable view. Normally, if you were doing a more complicated table, you would want to use the QTable view because it gives you more control, and actually is part of Qt's. It's one of many classes that use their model view interfaces, and so you have the reason why I went with a QTable widget is because it kind of makes it for a more simple example like this. We can actually just add items, and it kind of obscures the notion of needing to create an entire model. But if you were doing your own, it would be better to go along with an example with a QTable view so that you can have a little bit more control over what happens. But for this, we're basically going to set up, we know exactly what the columns will be in our case, and we know how many lines we have because we already know how many commits we have retrieved from our data parsing. The nice thing about if we had set up a model view with the QTable view, then you wouldn't have to set those limits on the column and row beforehand. It would just be reacting to what was inside the actual data. Have some pretty simple parsing logic here, just splitting each line based on the semicolon, and then creating a QTable widget item that's just a string, in this case from that actual data. and then setting up the dialog itself. And let's see what it looks like. I'm back in our demo level with our new changes loaded. So we can right click now on one of our prefabs. We see our new action for showing the Git history. We launch it, and now we have, voila, we have a nice Git history dialog that has a little table that shows the commit hash and the date that the change was made, the author and the title for the Git commit. And we can look at the other prefab, which has a little more history on it. And we can see all this in a nice table format. And then I'm going to jump back to the code really quick to make a small tweak to show some of the cool things you can do with just a few more lines of code. To make it a little more interesting, let's say we wanted to actually inspect a certain commit from our dialog. So let's change our logic to make the commit hash a clickable link that will actually take us to the commit view on GitHub. So this is the row where we actually currently in the table widget are just setting a simple QTable widget item, which is essentially a string reference, into each actual cell in the table. So we know that our first column is the one that has the commit hashes, so we're going to do something different in that column so that we get a custom widget that will actually let us actually click it and then take us to that commit hash in GitHub. So let's store off the string that's actually being parsed from our data so we can use it in either case. And we'll change this here. So then if we're in the 0 column, which will be our commit hash one, we're gonna do something different. If for all the other cells, we're going to continue just actually adding the QTable widget item, which is the simple version. So we're going to build an href link that we can actually display. So our link will be something like this. Now we'll use, in this case, I know I'm using the multiplayer sample project, and so we're going to just copy this link from here. If we wanted to, we could actually make this, again, pull from using the actual Git command line. We could pull the upstream from your GitHub and actually insert this here, but for ease of use, we're just going to go with that string. And so we can actually reference a specific commit by just adding the commit to the URL and then the actual hash, which we already have since we're displaying it. And so I'm going to display it as the link that we're going to click on. And then I'm just going to insert the value, which in this case will be the commit hash. I'm going to replace that with the actual, put that in the link, and that'll actually still also as well be what we actually end up clicking on. And so I'm going to create a Q label. And we're going to change its text format to be rich text so that we can actually set rich text in the text for it, and it'll be consumed as such. And then the other trick is we're going to say set open external links. And we're going to set this to true. And so this basically is when you have a Q label with rich text, it's going to, instead of processing the click event in the normal fashion, since it'll know that it's a link, and actually instead of emitting a signal for link activated, it'll actually instead open it using the Q desktop services open URL API. And so the final step is we're going to actually put this in our, instead of adding a QTable widget item, we're going to set this Q label as the widget for this cell. Now all of these APIs you can find on the Qt website. So like you can see here that the set cell widget, it has all the information about, you can set any you can pass any arbitrary Q widget that you want into to replace that in the cell. And then as well, you can see this is where I found all the information about the Q label. And so yeah, their documentation is really helpful to search through and find the different widgets and APIs on those widgets that will be helpful for what you're trying to implement. And that's it. So let's see what it looks like in the editor now. So back in the editor, we can go back and right-click on one of our prefabs, get to our history dialog, and it looks almost the same, except for now you can see the commit hashes look like a link that you can click on. And sure enough, if I click on this link, I'll be taken to that corresponding commit description. I can go down and now look at my player prefab. I can see, oh, this is what was changed. I can look at a couple of different ones and see that they are opening up the right commits. And you can see all the different aspects that were changed in that actual commit. And I can see that for any of the commits for all of the different prefabs that have history in the git log. So now we have this dialog example, but ideally we don't want to modify the engine code directly because it takes a long time to recompile and isn't very portable. So instead, I'm going to show you how to turn this example into your own custom tool that will live in a brand new gem. To create a new gem, we'll navigate to our engine folder, and we're going to execute a command from the command line. So we just need to run the O3DE script that's underneath the scripts folder. There's actually a batch script to help you do this on Windows. And we're going to pass it the create gem argument. And then all we have to give it is a path. In our case, I'm going to put it underneath the gems folder. And we'll call it the Get History gem, since that's the dialog that we're going to be creating. And now if I go under my gems folder, we'll see Get History gem has been created for us out of the default gem template with all the code necessary and the CMake files for it, so that we can actually add it to our project. So I'll come back to the project manager, go to the project settings, configure gems, find my new gem. We'll enable it and then save. We should get a confirmation message. If we go back to the beginning of the project manager, we should see that now we need to rebuild our project with our new gem enabled. Now, the reason for putting all of our work in a new gem is because this will allow us to enable and disable this functionality that we're adding. You could even bundle up your gem and send it to somebody, and they could just enable it in their project, and they would get this exact same dialog that you've built. So it's very portable. So now we're going to actually, before we rebuild our project, we're going to modify a few of the files that were generated for our gem so that it'll have the necessary dependencies in order to interact with the editor. So let's take a look at the folder that got created when we just created our gem. So we're going to go in our gem folder, find our Get History gem. And so all of this gets pre-created from the template. So it's mostly ready to go with a few exceptions for making a custom tool in the editor. As you can see, there are files for an editor module as well as a regular module. The difference being anything that doesn't say editor is basically going to be running actual at runtime for your game. Anything that you see that's editor is only getting compiled when you're building the editor. So that's the distinction. In our case, since we're making a custom tool, we really only care about the editor portion for that. So that's what I'm going to focus on. There are really only two files in here you need to modify, and then there's some that we need to add. I've already added a few of the files here, which are these three as well as this icon, and I'll go over each of them. So the first one is a QRC file that's basically a resource. It's a Qt resource file. We don't have too much in it. We basically only have our icon that we're going to use for the toolbar for our custom dialog. And so essentially these files set up prefixes so that you can actually reference image assets or really any assets inside of Qt, and so that you can use relative paths to them and set up different prefixes. You could also, of course, use absolute paths, but those obviously are not as portable. So these will set up nicely for you to be able to give someone your gem and it will just work. The next two files I'll open up in a second, which are actually a header in CPP for the implementation of our dialog itself. And then the last one is a little smiley face icon that I made just for the purposes of our toolbar icon. And so the files that we need to modify are really just this top level cmakes list.txt. So we'll open this up. And so we're going to go scroll down. Like I said, the stuff that's not for the editor, we don't really need to mess with for this case. What we really care about here is, in our case, our gem is called get history. So the get history.editor static target, we're going to add 2 lines right here. And the first one being auto-mock, which I'll explain in a moment, as well as auto RCC. So the auto mock is going to let CMake do some things for us as far as the meta object compiler, which is part of Qt. It does a number of things related to the meta object code that gets auto generated for Qt classes. Among other things, it's required for if you're using the signals and slots mechanism and runtime type information in the dynamic property system. So this one is important, and I'll kind of show you in our dialog class the necessary hookups so that all works correctly. And then the other one is the auto RCC, which again is for the resource compilation. So like we had shown earlier, this get history.qrc, this will make sure that this gets compiled properly for us so that we'll be able to use the resources in Qt. A lot of the actual dependencies we're going to get for free because of the template, and the editor target is pulling in this AZ Tools framework library, which has a lot of dependencies that we will use, especially for this tutorial. And so the other file that we need to modify is the editor files CMake. And so really all we need to add here is we need to tell it to include our 2 dialog files. So the source and then the header. And then lastly, the resource file. And those are the actually only files from the template that you need to modify. There are some files that we will fix up as well once we actually generate. And so now we can actually build our project, and we'll be able to see our new files in here, and then we'll be able to go from there. So I've reconfigured our project, and so now we should be able to see our gem loaded into the project solution. So we'll scroll in here. Sure enough, we have our get history gem loaded in the project, and we'll see all the sub-projects as well. So the first spot we need to modify here is we'll go into the get history editor target, and for you it'll be whatever you named your gem.editor. We'll go into its corresponding editor module. Now, since all of our code is in this gem module, we need to tell Qt to initialize the resource file that we added earlier. This, in our case, it's called gethistory.qrc. And so this is necessary so that it will actually be loaded correctly into Qt's resource system. And I'll show you why in just a second. And so basically all we need to do is add a couple lines at the top to initialize it. And there's a macro q init resource. And you give it a name, which in our case is just going to match, it'll just match the name of the file here that you have registered. So there, and then we will just call this in our constructor for our editor module. And so when our editor module gets loaded, when we launch the editor, it will initialize our resource for us. So next we're going to look at the two of the files that I added for our actual dialog class, which in our case will be our custom tool. Now your custom tool can derive from different things, and for the sake of our example, I'm just using a queue dialog, but it could be a queue main window, it could be any kind of widget that you want to display. So really, there's not too many lines in this file. I'm just creating a custom class that subclasses the queue dialog class. The couple of things that I did want to mention in this file are up here at the top. We have this not defined macro check for queue mock run. If you remember earlier when we were modifying this cmake lists.txt, we added an auto mock, and so that's the, as I mentioned before, that's the mock compilation process. And so what this does is actually helps the mock compiler run faster and actually also prevent some failures. So mock runs kind of like a compiler, and so it will actually include the headers, but they're not actually needed for the mock, and so it'll run faster if these are excluded. But more importantly, there are actually some bugs related to namespace detections. And so if you don't have this in your header file, it could potentially produce compilation errors in some cases. And so this is a good thing to remember to have in here. The next thing that might be different is this queue_object macro. This is what actually sets it up so that the mock process will be able to find our class and will actually generate a mock file for our class. And that will be, there's another piece of this that we'll need to include later as well. And so if we next look at the Git history dialog implementation itself, again, really not too many lines. We're including our header file, and then I've included two queued classes that I'm going to use in our dialog, a label and a vertical box layout. And so similar to our other example we had where I set the window title to Git history, I've got a VBox layout. For the purposes of this first example, I'm just going to show again, we have our hello world. It's added to our layout, and so it's pretty straightforward. The only other line I wanted to really go over, though, is this bottom one for the mock. And so this isn't technically necessary, because if it's not there, our mock compilation config file that got generated from the template will actually include it for us. But it's recommended to add, since it'll be more consistent when you have generated UIC files, and it keeps all the symbols in the same translation unit. And so this one really is just allowing the compiler to make sure that we include the mock file that gets generated for this dialog. So the next file that was part of the template that we need to actually modify to register our tool is we go to our editor system component. So this came from the template, and this actually already is nice because it is already inheriting from the editor events bus for us, which has a lot of events that we're interested in. The one in particular that we're interested in is we're going to override the notify register views API, and this gets invoked when your system component gets registered as part of the startup process for the editor. This is going to get called once the editor's view pane management system is initialized and ready to accept registration of custom tools. And so we don't want to do it too early. Like if we put it in the constructor for our system component, it would be the API call for registering our tool would be missed. So we want to make sure that we do them in this notify register views. Everything else in this file is good as is that comes from the template. So lastly, we'll go into the editor system component CPP itself. We need to add one include at the top for some view pane options for our custom tool view pane. So we're going to say include AZ Tools Framework API view pane options. And we'll see what this does in a moment. Everything else in this file is good as is from the template. And we're also going to include our Get History dialog that we added before. So we'll come down, we'll make our implementation of that method, notify register views. And so what we're going to do in here first is we're going to set up our view pane options. We can take a quick look at this class. There are a lot of options in here. A lot of them have good defaults that will be necessary for you. The only ones that we're going to override, we're going to give it a default size. We're also going to, for our case, we're going to say we want to show these on the toolbar. By default, this is set to false. So we're going to set this to true. And then we're going to, the last option we're going to override is the toolbar icon. And so this is where it's going to come in to play the resource file that we had registered earlier. So if we hadn't have done the modification here to initialize these resources, relative imports wouldn't work here, and we'll show you what this looks like. So because in our resource file we have registered a prefix of get history and then we have our icon name, we can do this in our view pane registration. So we can just say get history smiley icon.svg. And so without that, we would have had to do an absolute path here, which of course would not work if we tried to give our gem to anyone else or even anywhere else in our project. And so that will actually register a toolbar icon for our tool, as well as the menu action that will open it and close it. So the last is just we need to actually register our view pane. So this API, you just give it a template. In our case, we're going to give it our history dialog. And this takes a couple of arguments. We're going to give it the name of what we're going to call this view pane. We're going to give it a category. This is where it shows up in the menu, and I can show you what the other, if you modify this, what ends up happening. And then lastly is our view pane options. So let's compile it and see what happens. All right, I've relaunched my editor, and now we can see my beautiful smiley icon. If we click on this, we get our custom tool, which in our case right now is just a hello world, but still very neat. And so this can be now actually, before it was just a dialog that was a pop-up, but now this is actually just like all the other tools that come with the editor, such as the outliner, asset browser, entity inspector. This can actually be docked anywhere now in the editor, just like any other tool. And if you actually closed the editor and relaunched it, its position would be remembered. You can keep it floating, you could dock it in the middle of these panels. This can be anywhere, and this is a fully registered tool. So if we go under tools, we can see it here as well, get history. You can see it, since it's shown visible, we have a check mark by it. We have our icon we can see here, and so we can actually toggle it via this menu as well. And you can see as well on the toolbar icon, it is shown with the blue outline when it is visible. And again, if we hide it, then we can see that goes away, and click it again, it'll come right back. And so there is our tool. So now let's port over the code that we had done earlier for the actual menu action for the prefabs, and we're going to put it in our dialog. Back in the code, I went ahead and already ported over our logic from the action menu into our dialog that we stuck our Hello World example in. I just want to go over some of the key differences. First one being that now our dialog derives from the tools application notification bus. There are a lot of APIs on this bus that will be interesting for any custom tool. The one in particular for us, though, is when the selection changes in the editor. I had to modify our example slightly, since before we were actually reacting to a right click on a prefab. Now that our tool is just in the editor, I modified it slightly to actually respond to investigating when the selection changes in the editor. We'll inspect the selected entity and determine if it is a prefab, and if it is, then we'll go ahead and run the exact same logic we were doing before for grabbing the git log commit history. So in the setup for the history dialog, really the only differences here are I'm using a stacked widget so I can switch between a queue label that just has a little warning message from for the user saying please select a prefab. And other than that, the table widget setup is still the same as we had before. And so the queue stack widget just allows us to switch between any number of indexes and show a widget in one single location. And so that stacked widget is what I'm actually putting now in our main layout instead of the table widget itself. The next key difference is you can see at the end of the constructor, I'm connecting to the tool's application notification bus so we can listen for when that selection in the editor is changing. The method in here is responding to when the selection changes in the editor. If we have too many entities selected or there's no entity selected at all, we'll go ahead and just show that warning message. In this case, we're only interested in if the entity is a prefab or not, and so this logic protects against that. And then other than that, the logic is pretty much the same. We grab the prefab file path, we run the git log to get the data, we parse it out and set it on our table widget. And then if in the case of actually once we've constructed our new table, we change our stacked widget to show our table view instead of the warning message. One other small difference here is the table widget, before I add more data to it, I'm clearing out the contents. There is also a clear method, but that would get rid of our headers. We want to leave those in, so the clear contents will just get rid of the actual data, and then we set our new row count. So let's see what it looks like. Back in the editor now, with our changes compiled, let's go ahead and launch our tool. We have our message first telling the user to select a prefab. If we click on a regular entity, nothing happens, which is what we expect because they're not a prefab. If we click on an actual prefab, we'll get, just like we had before, our actual table with all the data, and the click on the commit link still takes us to the GitHub commit for that actual commit. And we can click on the different prefabs and see all the different data. And we can even dock this view pane anywhere now in our editor, and it'll still work as intended. So now we're going to remake this same custom tool, but in Python instead of C++. To get started writing tools in Python, all you need to do is go back to the project manager and go back to your project settings and enable the Qt for Python gem for your project. This will give you access to the PySide2 library, which is the Python bindings for Qt. And so this will give you access to the entire Qt API, only in Python. Back in the editor, once you've enabled the Qt for Python gem, you'll notice a new tool becomes available called the object tree, which I mentioned earlier in the presentation. This tool is written entirely in Python, and as you can see, has been registered as a tool that's a dockable pane, just like our tool that we created earlier in C++. This tool allows you to inspect the actual widget hierarchy of the entire editor, so you can mouse over any item you see and actually click on that and get some metadata information about the type of widget it is. And then as well as you can see its place in the overall full Q object hierarchy of the entire editor. This is really useful if you're wanting to kind of inspect different tools that already exist in the editor and see where they show up in the code. For example, in this case, I clicked on the Add Component button in the Entity Inspector, and I can see, oh, this is the Q object name for that widget. And so I can go back into the code base and actually search for this Q object name. And this takes me exactly to where this shows up in the code. The Python code for this object tree tool lives inside the Qt for Python gem itself, underneath the editor and then scripts folder inside of this show object tree Python file. So now we'll go ahead and jump back to our Git history gem, and I'll show you how we can register our own custom Python tool that'll match the behavior of our C++ Git history tool that we created earlier. Back in the folder for our Git history gem, you'll notice I added a new folder matching the same that you saw in the Qt for Python gem. So underneath editor and then scripts, we have two files here. There's a bootstrap.py and then our actual Git history dialog. The bootstrap we'll look at first. this is the actual file that, based on this path, if you have an editor and then script subfolder and a bootstrap.py, when you have the Qt for Python gem enabled, this file will be looked for in your gem, and this will be executed as part of this startup for the editor environment. In our case, there's only a few lines. These azqt helpers we grab from the Qt for Python. These are a few helper methods that we've written. And then all we do is register our view pane, very similar to the way that we did it in C++. We just give it our name, and in our case, we'll give it our dialog that we get from this local folder. And so out of our Git history Python file, we've got our Git history dialog. And you'll notice the code looks pretty similar to what we wrote in C++, only now it's all in Python using the pysat2 library. And really the only distinction I wanted to call out here is there's a slightly different way for, in C++, if you remember, we used the E-buses for listening for when the selection in the editor changes. In Python, it's just slightly different in order to do that. You set up a handler for that E-bus notification, and then you connect to it, and you can add a callback for any of the methods on there and pass it a local method. And the only thing I wanted to call out was that this handler needs to be saved onto your dialog or widget, or basically it just needs to persist, because if this ends up getting deleted or going away, if you just set it up in the constructor, then the actual handler and the callbacks will get deleted. So you just need to make sure that this variable lives on past the construction of your dialog. So if we go back now into the editor and we go to Tools, we still have our Git history that we created in C++, this dialog, but now we get a new one for Git history in Python. That's the name we registered it with in the bootstrap.py file. And so we can launch our tool. You notice it looks very similar. We can dock it, do all the things with it as a registered view pane as we were able to do in C++. And if we select a prefab, and we get all the prefab data just like we had done before in the table, and we can still click on the commit, and it'll take us right back to the GitHub repo for that commit and all the changes that were made with that log. One of the cool things about writing tools in Python is, since it's not compiled code, you can iterate on it much quicker. So if you go through the Python scripts tool, you can actually relaunch this tool at any time. And so you can see here, right, this is the default state of our Git history dialog. If I close this and I go back to my code, I can change this message for when you don't have a prefab selected to something like hello world. You can save that and go back and relaunch it, and there's your change. Unfortunately, it's all the time I have for this talk, but if you have any questions, I encourage you to join the O3DE Discord server if you haven't already. If you are new, you can find it on the O3DE org website, and then under community, you can click on there's a Discord chat link, which will take you to our server. And specifically, if you have questions around extending the editor, under the SIG UI UX channel would be your best place to find myself or many of the other active people in the community. Thank you for your time. Once again, my name was Chris Galvan. Hope you have a great day.